These notes are over matter. So atoms and molecules make up matter, so everything. And then matter can be further divided up into pure substances and mixtures. Substances can be elements, which is going to be one type of atom, or compounds, which are two or more different atoms combined in a fixed ratio. Okay, that fixed ratio is very important. So if you have a particulate diagram of an atom, these are particulate diagrams, of an element. If you notice, every single one of them is exactly the same. So elements only are one type of atom, and they're found on the periodic table. If it's not on the periodic table, it's not an element. Compounds are in a fixed ratio, so you're going to see a pattern when you look at your particulate diagram. So if you notice this one, you see one green, one purple, one green, one purple, one green, one purple. There's a pattern. That tells you it's a compound. With mixtures, there's a variable ratio. Okay, so no pattern. And then they can either be homogeneous or heterogeneous. Homogeneous solutions are going to be very well mixed. So you won't be able to see the individual atoms or any kind of chunks. Heterogeneous mixtures, you're going to see a definite chunk of something in there. You can see the different particulates. It's not well mixed. Okay, then we've got our three states of matter: solid, liquid, gas. And if you notice, the solid particles are very, very close together. There's no movement. They just kind of vibrate in place. So for a solid, they have a definite volume and a definite shape. And they are not compressible. You can't get those particles any closer together. With a liquid, now there is a little bit of room in there. They're a little more free to move, a little more energy between them. They do have a definite volume. They do not have a definite shape. They take the shape of whatever container that they're in, and they are also not compressible. At least for our purposes, they're not compressible. Then a gas, lots of space between the molecules, high energy, no definite volume, no definite shape, and they're very compressible. Okay, so this is an energy diagram. Along the diagonal are going to be your states of matter: solid, liquid, and a gas. Okay, if you're solid, you're going to add temperature, add heat. As you move along this way, you're starting to become a liquid right here at this point. That's when you start to melt. So that would be your melting point. If you're a liquid and you're traveling along this way, this is the instant you start to freeze, your freezing point. So as you travel along this line, you're freezing. Now if you're a liquid, this right here is your boiling point. So as you move this way, you are boiling. If you're a gas, as you move this way, you are condensing. Boiling is also called evaporation. Okay. So these freezing, melting, condensing, evaporation, those are all phase changes. You're going in from one phase of matter to another. There is one more, there are two more that's on here. If you're a gas, you can go straight to a solid, and that is called deposition. If you're a solid, you can go straight to a gas, and that is called sublimation. So these are all the phase changes, and you need to know them. All right, here are your homework problems. We'll check them in class.